Hi everyone, welcome to our webinar today. Just wait for a few more people to join and then we'll start. This is our Through an Attacker's Eye, your web applications webinar today, following on for our advanced web hacking training courses. So welcome everyone who's just joining now. We'll just wait a minute or so for more people to join. Welcome to everyone who's just joining now to our advanced web hacking webinar today. Hope you've all had a lovely day so far, wherever you are in the world. Just wait a little more moments now. Welcome to everyone who's just joined us for our Through an Attacker's Eyes, your web applications webinar today. Okay, great. We might as well get started then. So I'll pass you over to Alan now. Welcome everyone who's just joined.
Thank you, Lizzie. Oh, hi everybody. Thank you very much for your time, and hope you're keeping your chin up in this rather unusual times. And I know everyone's got their fingers crossed that 2021 could be a better year than the last year was. Anyway, my name is Alan Panting, as mentioned. I'm quite lucky enough to be a part of a great role in a global team, and my job really is to help deliver what we consider a world-class ethical hacking and training service. Shortly, I'll be handing over to Juve, who is one of our security consultants and also one of our black hat trainers, and he's also an accredited pen tester, so he's well geared up on the subjects you're talking about. If you don't mind, before we start, I'd just like to give this opportunity to tell you very briefly a little bit about us. Not So Secure is part of the Clarinet Cybersecurity Group, and we do two main things effectively: we hack and we teach. When I say two things, they quite a lot of things under those banners, you know, including pen testing, red teaming, consultancy, training, and a lot of other clever things like MDR security testing, continuous security testing, and other consultancy services. We've got about 20 years experience doing cybersecurity, so I like to think we know the subject pretty well by now. We also feel very proud to call ourselves the largest hacker trainer for the world famous Black Hat events, which run alongside DEF CON, and the big events are in Vegas every year. And at that event, we train about 500 or 600 people in this very subject that you'll be talking about today. So get pretty good attendance at these events. So hope you enjoy what we're going to be talking about. On the training side of things, we also partner with a lot of other training organizations such as QA and Checkpoint, just to name a couple. So about web apps, effectively web application vulnerability is on the rise all the time, and as you know, it only takes one small crack to break a whole dam, and the consequences of that will be disastrous. So when it comes to web applications, getting hacked, the consequences are pretty disastrous in a lot of ways because it's a way into your system, into your processes. So the old saying, really, the prevention is better than cure, it definitely does apply when it comes to this sort of thing. Today, today's talk, we're going to give you a few flavors of the more advanced hacking techniques. But I'd like to point out that the webinar is just to really give you a flavor. The actual training course we run is obviously a lot longer than 1 hour like we got now, and it covers a lot more depths. But this is really just a sample for it. And the actual training course itself has been built up over a period of time and been improved month on month. Just to make sure it meets the current times and customer demands. Also, just to point out, we're running promotion at the moment. Bit of a double-edged sword on the promotion. Just by attending this webinar, we'll give you 20% discount to any of our training courses. And also, if you want to have a chat with any of our trainers, we'll enter you into a free prize draw to actually have a free place on one of our training courses. That's all the boring bit over with. I'd now like to hand you over to Jude to cover the interesting part. Jude, can you take over for me?
Awesome. Thank you so much, Alan. All right, guys, welcome to this webinar of Through the Attacker's Eyes for your web applications. Little introduction about me. My name is Dhruv Shah. I'm an associate director at Not So Secure. I have written 2 books, Kali Linux Intrusion and Exploitation and Hands-on Pen Testing using Burp Suite via Packet Publishers. My expertise is in the field of mobile, web application, and network security. I've delivered this particular advanced web hacking training at multiple locations like Black Hat in Vegas, Singapore, Chicago, Tokyo, all since 2010 and ongoing. Hack in Paris, OWASP, AppSec Tel Aviv, Virginia, Japan, Texas Cyber Summit, NordSec 2020, etc. Right? Now, why exactly are we here in this webinar, and what does our training offer? Now, to give you a gist, if you look at normal pen testing, most of the web application level vulnerabilities that are reported focus only around the top 10 web application vulnerabilities, right? That is the top 10 categories of OWASP. Now, usually from the defender's perspective, most of the time, the application security or the application's defense lies on the efficient development and protections against vulnerabilities that are detected by automated scanners. And most of the times, organizations rely on just the automated scanners to find if their infrastructure or if their applications are vulnerable. Now, for the modern day attackers, the attackers know that the common analysis is usually with the help of automated testing, automated scanners, and the core focus should always be around manual testing or scans of vulnerabilities that are usually undetected. And quite a lot of times, because of out-of-the-box thinking, the attackers are able to succeed in these kind of attacks. Now, our aim here is to basically walk you through some of the most interesting scenarios that we have encountered in our real pen test engagements, and taking out of the box vulnerabilities as well as sophisticated test cases, allowing you to exploit certain vulnerabilities. A little bit of plug. All the demos that are shown during this particular talk or this particular webinar are from our real environment that we use for the advanced web hacking course. So without wasting time, let's jump into it. The whole training has been designed keeping these few principles in mind. The only way we take a topic for consideration or within the syllabus has to undergo these following criteria. One, it has to be a vulnerability that usually goes undetected by automated scanners. Two, these are very twisted bugs or out-of-the-box test cases, which we prepare in our day-to-day pen test and we end up succeeding. A few amazing bug bounty reports, and certain sophisticated business logic flaws. Given they satisfy this criteria, we go ahead and add it in our course, and we ensure that the attendees get the experience of playing with this vulnerability in our simulated lab environment. So this is how our course looks like. This is the part one of our course. If you see, we have topics ranging from advanced authentication and single sign-on, password reset attacks, business logic and authorization flaws, XXE attacks, breaking cryptography, right up to remote code execution, tricky file upload. Continuing the syllabus, you have SQL injection masterclass, server-side request forgery, cloud pen testing, attacking hardened CMSs, web caching attacks, miscellaneous vulnerabilities that cover interesting attacks like Unicode normalization attacks, second-order IDOR, even exploiting misconfigured Git systems, prototype pollution attacks, desync, etc. Now, most of these vulnerabilities, or I may say almost all of the vulnerabilities that you see here, have an embedded lab in our configured lab environment to go ahead and play with. So the ones that are highlighted are the ones which we are going to talk about in this session that we have for 1 hour, right? So without wasting time, let's move to the first attack, that is attacking SAML authentication. Now this whole attack scenario, this explanation is just to give you an idea what you should expect in the course and what will be the type of content that will be taught, right? So let's jump in and try to understand how to attack SAML auth. Now, SAML is nothing but security assertion markup language, and a SAML basically is an authentication that provides users credentials login interface. That is, there is an identity provider that behaves as the authentication portal, whereas all the other websites can come under this identity provider and become the service providers. Now, SAML requests are basically XML documents which are basically encoded and passed on to the service that needs the access to it, right? Now, rather than going into the theory, the best idea is to understand the scenario of how the flow works. Because the better you understand the flow, the more the possibilities of you to come up with new attack vectors. So let's go ahead and understand how the flow is. So here, as you see, we as a user, I'm going to use a highlighter. So we are a user, and the service provider is a website, whereas the identity provider is the IDP, or the SAML authentication provider. Now, when a user visits the website and observes that the website has an authentication page, the service provider or the website first sends a discover IDP request to the identity provider. The identity provider goes ahead and verifies whether the user is allowed to, the website is allowed to have the particular service or not. If yes, it says the website that, hey, can you please redirect the user to the particular single sign-on service? Now, once the user is redirected to the single sign-on service, he has to provide the user ID and password. Once the credentials are given successfully and the authentication succeeds, the identity provider provides an XHTML form, which is base64 encoded, along with certificates and signed documents to ensure that tampering does not take place. And this particular document is forwarded to the service provider from the user agent, right? So this is an important part to understand, that that particular request is sent from the user agent to the service provider. The service provider validates whether the document is correct or not, and if it is, then it redirects to the target resource and it fetches the content and shows it to the user. So this is exactly how a normal SAML workflow is. And to have a look at how the document looks like, let's go ahead and look at the document. So this is how the response of a SAML structure looks like. So you have a response destination. This is one of the destination in our web hacking lab. And this is the particular user that is authenticated, that is sunil@notsosecure.com. So this is the user that will be authenticated if this entire response is validated and it is correct, right? Now, in a normal pen test scenario, what the attacker would usually do is simply change this email address to the attacker's email address and forward it to the particular web application. And if the web application is not properly configured, then there is a very high possibility that the attacker is able to bypass the SAML mechanism. But as I said, we're here to understand advanced level attacks. This type of an attack would be a very basic or a small common attack. What is the other way around to bypass this, where if I change the email ID, the application throws an error that incorrect data found or tampering found cannot log the user in? Let's go ahead and have a look at it. So we discussed scenario 1, replacing the email ID with the attackers, and it works. But in our case, it did not. So what is scenario 2? Now, in order to understand SAML authorization bypass, we need to understand that it uses certain set of features. One, we already know that it uses XML to parse the data. And second, there is something called as canonicalization engine that runs when SAML implementations are done. Canonicalization engine is basically a mechanism that allows you to represent data in a different order, but the meaning of the entire document is same. So to give you an example, if I go back, if I specify this particular name ID after the subject confirmation, it still has the same meaning, but only the position has changed, right? So if the position is changed but the meaning is same, then a different signature need not take place, is the mechanism on which the canonicalization engine has been implemented. So we are going to leverage that canonicalization mechanism and try to do a bypass. Now, the problem with canonicalization is that by default, canonicalization engine ignores the spaces and comments, right? So it ignores spaces and comments while creating a signature. So if I, as an attacker, am able to inject spaces and comments somewhere in the document in such a way that I can bypass the authentication, it would be amazing. So what do we do? How do we attack? This is exactly what we do. Now, let's say there is a user called as not so secure user at the webhacklab.com whose access we have, and we want to log in as user@webhacklab.com. We can leverage the canonicalization mechanism and say this is a comment and inject it between not so secure and user. What will happen is it will happen in such a way. When it reads this entire line, as per canonicalization, it is supposed to ignore the spaces and comments, because of which it will not change the signature. The signature verification will be correct, and when it proceeds to authenticate the user, the XML parser takes this document or take this particular value and it breaks it into three parts. The first one is not secure, the second one is a comment, and the third one is user@webhacklab.com. And when this is parsed, the XML parser usually ends up taking the last value or the last text, that is user@webhacklab.com. So let's go ahead and see the practical of how we can do this in our lab, right? So I'm going to go ahead and play this recording. So I log into the application. Now this is a particular application which is designed in our lab. Let's go ahead and see how the SAML authentication works. So I sign in with SAML. I go to one login. So we'll access the one login page. I'll provide a username. So the username I'm giving is not a john@webhacklab.com, because my target or the actual victim I want to compromise is john@webhacklab.com. So let's see what happens. So I log in. The identity provider will verify, and now it is trying to redirect me to the actual application with the SAML certificate. So let's see how that goes. So I forward the request, and if you see here, I have a SAML response. Now I'll forward the response. I'll basically check the values of it. So if you see, there you go. So that's the email ID that validates that this is the signature for this particular ID, and we'll play with this. So let's first verify the actual details. So I'll send it to the server, take the response. So it says, okay, that's a correct user. I'll let you log in. But now if I change that value from not a John to just John and send it, then it says failed, which means that there is validation in place. But I need to bypass the mechanism of canonicalization, so I will add a comment, right? So I add this as a comment and I send it. Now if you see, it says, yes, it's a valid user. Let me log that user in. So if I simply request that in the browser, go ahead, request in the browser. You see, we are logged in. We are logged in as john@webhacklab.com. Then later in the class, we obviously go ahead and discuss the different attack scenarios and how the different attacks pan out from here. The other attack that we'll discuss is XXE in file parsing, right? Now, a very interesting test case for XXE attacks is actually document files that allow you to upload documents on web applications. Now, Open Document Format is an XML-based file format, and you'd be amazed to know that most of the doc files or most of the documents that we use on a day-to-day basis to upload the documents are running on Open Document Format. To give you an example, you have docx, you have pptx, xlsx, odt, ods, pdf, and most of them are nothing but XML collection of XML files which are zipped together and passed for processing. Now, since they are a collection of XML files, it obviously arises us or gives us a possibility of trying to exploit XXE vulnerabilities within them. So how can we do this? Well, it's pretty simple to understand the flow. So if you see, we simply open one of these documents. Let's say it's a docx file. So we simply open a docx file in a VI editor or in Notepad and try to access any XML file and inject our XXE payload. We upload the document file and observe whether the application executes XXE in the docx or not. Now it's pretty obvious that we cannot spam XXE payloads in each and every document. We need to identify that if the application is indeed processing something from this particular doc file, where exactly should I put my payload, right? So how do we do that? Let's go ahead and have a look at the video. So I go to one of the applications. Let's wait for it. And I scroll down to one of the features that allows me to upload a document. So I just fill in my details. So I give a name, mobile number, and email. And now I'm uploading a file. So the first file that I upload is a straightforward file called as resume.docx. Now this file is basically an empty file. It just contains some garbage data. And we go ahead and we try to upload it. So let's see what happens. So it says the resume has been updated successfully. And if you see here at the top, it says title, my title has been added, right? So let's try to understand what exactly is this title, my title has been added. So let's do our analysis. Let's check it out. So I go back to the history. I check that particular request and I check how it sends a response. So it says title, my title has been added. All right. So I open the BI terminal and I try to see that particular document itself using a BI editor. So I open the particular file and I try to locate from where did it find the my title details. Now if you see, it's a collection of XML, but this core.xml file where my cursor is right now was the actual place where this particular information was available. So I'll go in this file, and if you see DC title, my title, this is the exact place from where the parser read this value and it showed it to me on the screen. Now, if it showed it to me on the screen, which means that the XML parser is reading it, and if I inject XXE payload in this particular XML file, I might be able to do a proper XXE attack. Let's go ahead and see if we can do that. So I have another file, resume2.docx. I'll open this file. I'll show you the core.xml. So we go to core.xml. And if you see, I have my XXE payload trying to fetch the details of etc pass WD. And in the title, my title, I'm referencing the particular parameter, that is the general entity. So this is my particular payload. I'm going to save this document and I'm going to upload this document. So we'll go to the career options again. We'll fill in the data. Right, so I just spam in my email ID. I upload the resume2.docx and I see and I try to understand if my XXE executes or not. So I upload the document, and if you see in the background, we are able to extract the contents of etc password. Isn't that interesting? Let's have a look at it in Burp. Right, so I was able to extract the contents of etc password via a file upload functionality only by the understanding that when I upload a docx file, it is reading something from the doc file configuration and fetching it to the user. Now, all this skill is only possible if you go ahead and try to understand or basically upgrade yourself to the different types of attack vectors that have been explored or that have come out in the market. So as I said, these are like the criteria which we see that automated scanners would not be able to pick them up. But getting the skill set or getting the idea that if there is some functionality like this, you might be able to test these kind of test cases is exactly how we aim or exactly what we try to do in our particular course. Let's move on to another interesting topic, that is .NET machine key auth bypass. Now, before we jump into what the auth bypass machine key is, let us understand what is a machine key. Machine key is something that is used for the encryption and decryption of forms, cookie data, view state data, and other out-of-process session states within the .NET framework. Now, when you configure a machine key, it has to be done within the web config file, and this is how the syntax reads. You have, let me use a highlighter. So you have machine key, validation key, you give your particular validation key, you give your decryption key, and you specify the type of encryption that you want to use and the type of encryption signature that payload that you want to use. Now, what is encrypted with machine key? So you have authentication tokens, web resource.axt, script resource.axt, view state, CSRF token, password reset tokens, role, cookie, membership passwords, etc. So if you try to understand what is the role of machine key, it has everything to do with most of the contents that are encrypted in a particular ASP application, which is hosted on the internet or on the internet. Now, what exactly happens? Now, before we jump on to the conclusion, let's say that there is a developer who basically created a .NET application and was able to use it successfully. But after one point of time, since the application gained a lot of interest and it had to be, scaled higher, the developer went ahead and created multiple different servers and put them under a web farm. Now, what happens with machine key is that by default, machine key is automatically created if it's just a single isolated server. But when you put it in a web farm, every server ends up by default having different machine key values. In that case, the web farm will not work. So if a web farm does not work, what does the developer do? The developer first goes online on the Microsoft's documentation or Stack Overflow or .NET documentation to figure out how to fix this particular error. It so happens that when the developer stumbles upon the particular documentation of Microsoft, if you see troubleshooting scenario 5, if the scenario involves a web farm, then the machine keys should be same across everywhere. Use below machine key to maintain the consistency on all the servers of the farm. So the developer is like, all right, so this is the mistake I was making. Let me just simply copy this key as they have said that use the below machine key to maintain the consistency. And I'll paste this key in the web config of all the different servers. He did that and the application was working perfectly, which means case closed for the developer, the application can be pushed for production environment. But here's the problem. If the attacker knows that there is a very high possibility that this is the particular machine key that was used, then the attacker does not even need to pen test the application. It is so dangerous that the attacker can simply use this machine key and create his own set of payloads. Now, let's say the developer did not go to the Microsoft's documentation. Maybe they went to other sources. Maybe, let's say, they went to Stack Overflow. Some good Samaritan or some good gentleman or someone basically comes and says that, okay, hey, I know you're facing a problem. Why don't you go ahead and do this? This is the machine key that you should use across all your systems so that you'd be able to get your applications hosted and running successfully. So if you see there are 32 upvotes, which basically means there might be a possibility 32 people actually use this particular key and they played with it. And if you look at the Git repositories, there are so many machine keys that are publicly exposed. Now, what can you do as an attacker? How can you take leverage, or how can you explain that exposing your machine keys is a very dangerous concept and using leaked machine keys is even more dangerous? Let's go ahead and look at the video to understand how you can exploit this particular vulnerability. So we go to one of the applications that is on .NET and that is using machine keys, right? So let's hit it. So access the application, and if you see here, there is a ASPX auth cookie. This ASPX auth cookie basically uses encryption with the help of machine key. So I'll make a note of this particular key, and I will go to one of the utilities. So let's go to that utility. Now we have created this utility within our internal network, and the particular source that we are going to use, or the tool that we are going to use, is called Blacklister, right? Now Blacklister is one of the tools that we have developed while we were pen testing our cases and discussing on how dangerous machine keys are. So Blacklister is a collection of leaked machine keys over the internet, over the GitHub platforms, or over Stack Overflows, and on the Microsoft documentations. So all the user has to do is just take an authentication key, the authentication cookie, and put it in this particular tool, and the tool will run it against all the machine keys that are available from the leaked database, and it will show you whether or not it is using a leaked key or not. This particular tool is open source and it is available on our Not So Secure's GitHub profile, right? So let's go ahead and see how the blacklister tool works. So I'll go to blacklister and I'll put the encrypted cookie out here. I'll say it's an ESP XOR cookie and this is the default algorithms that are going to be used. And we'll try to decrypt. Now if you see, it says, hey, I was able to use this particular decryption key and I was able to decrypt the data. So let's see what the data is. So you have validation key, decryption key, username, and user data is anonymous, which obviously will be because it's the first user visiting the application and he's not even authenticated. Now let's try to see if anonymous works. Well, it doesn't. So let's go ahead and see what else can happen. So I say administrator and I give a password. Now if you see for anonymous, it said invalid username and password. However, when I try to log in as administrator, it still says invalid username and password. But when I log in as admin, it simply says invalid password. So one important thing to understand is when you're doing the machine key exploit using blacklister or exploiting this particular leaked machine key, you need to know the username because you have to create that particular user's cookie, right? So here we have given you a hint that admin is an existing user. So let's go ahead and see what else we can do. So I try to now find a particular page that might require authentication. Images page, it says 404, it says not found. The home folder says 404, not found. But if I access the home/about, it redirects me to the login page, which means that there's a very high possibility that it requires authentication. Now here we've obviously shown you a small manual approach, but in the real pen test, you'll use utilities like Directory Buster, GoBuster to map or find out what are the different folders and directories available within this particular application, right? So just to save time, we showed you the shortcuts of how to enumerate for possible pages and pages that are not found. So now we know that we have a page that requires authentication. We know there's a user admin, but we don't know the password. How can we use machine key exploitation via blacklister? Let's see that. So I say I want to edit the cookie, and I say the user data is admin, that's the user, and the username is admin. Can you please encrypt and create a cookie for me? You see how dangerous this is? So I simply have created a cookie using that particular machine key that was leaked. And now I access the home about page, intercept the request, right? So let's go ahead and intercept. And I just replace that cookie with the malicious cookie I got. And I check the response on the server. What's the response? Let's have a look at it. Bam. I am an administrator on that particular application. I've not even started testing the application. I have not even scanned the application. I only checked whether the application is using an exposed machine key. It was using an exposed machine key. So we leveraged this functionality, found out an existing user, and we created a valid cookie of that user and started using the application. And there's no way any automated scanner can ever tell you about these types of vulnerabilities. One has to have the knowledge of how do these types of exploit takes place and what are the background or what are the bias on which the applications have been built, right? So this was .NET machine key exploitation, right? So I hope you like this one. The next one that we'll be looking at is insecure deserialization on .NET. Now, we all know what serialization and deserialization is, right? Serialization is basically a means of translating data from one form to another, and it is usually used to transmit the data across the network. To give you a normal textbook definition, I'd say that serialization is a concept of converting an object into a stream of bytes, sending it to a file memory or to the database or to the network, and then converting the stream of bytes again back to the object. But textbook definitions really do not make enough sense. So how do we understand in a day-to-day implementation? Let's say there are two people online playing games with each other, a multiplayer game. Let's say they're playing FIFA or soccer. Now, if you see in the game, um, there are different combinations that take place. Let's say there's one player or one person who's playing the game, selects a particular player, moves the player few steps forward, few steps to the right, and few steps forward again. Now, the concept of moving forward, right, and forward are nothing but few objects that are called in one after the other. Now, these objects get converted into a stream of bytes, are sent over the network to the other person who's playing the online game with this person, and it passes this object, it reads these stream of data, and it converts it back into object for the game to be able to read it and process it. So as soon as it is sent over the network, the stream of bytes is converted back into the object. When the objects are read in sequence, it will read few steps forward, few steps to the right, few steps forward, and this is how people will play with each other. So you understand the concept. Now what's dangerous in this? The dangerous thing in this is that the other end has no control over what it is supposed to expect as a value that has to be deserialized. And the attackers have leveraged exactly this particular endpoint to cause or do remote code execution. Now, in the class or in the training that we do, we usually cover the Java frameworks, Java containing XML, binary, and JSON, whereas we even cover .NET serialization, Python serialization, etc. But here we'll be looking at .NET. Now, serialization, as I said, is everywhere. It's almost there in all of the languages that are here. Like if you see Java, PHP, .NET, COM, Ruby, Python, and all the other OOP-based languages. Now, most of them, almost most of them, had bugs and deserializations that led to remote code execution. If you have a look at this, it's a big list of CVEs that were all vulnerable to deserialization attacks. So what's with .NET deserialization? How do .NET deserialization attack takes place? Now, .NET framework has multiple serialization types. You have the top serialization methods that are binary serialization, XML, and data contract serialization. What we'll be looking at is binary serialization. So the .NET framework provides the binary formatter class for binary serialization. And binary formatter is the most common class that you will see in the .NET application that is used for the serialization purpose. Now, what is the particular class that it uses? It uses system.runtime.serialization.binary formatter class, and it's a serialization mechanism in the framework since 1.0. Now, we are not interested with the theory. We just want to understand how to identify these types of attacks, right? And how to understand or how to create our payloads to see how the server responds and be able to see whether it is vulnerable or not. So the first thing to understand is whenever you want to find out whether a particular set of data or a particular set of block is containing .NET binary serialized data, you have to focus on the particular value that I'm going to highlight. So let me use the pen. So whenever you're pen testing, if you ever come across a string that has this particular initial signature, that is AA, EA, AA-D with a few slash, it is using binary formatter serialization output. This is .NET binary serialized data. And if it is, then you can leverage the particular attack, or you can leverage this particular implementation by creating payloads with the help of visor-serial.net. Visor-serial.net is another utility that is created by basic pen testers and researchers that allow you to leverage .NET serialization vulnerabilities in that platform, right? So let's go ahead and see how this particular attack can be exploited. All right, so I have this particular application. Okay, now we'll go ahead and we will try to see where the data is. Now, if you look here, you will realize that there is ASPX auth cookie, there is request verification token, and there is something called as NSS temp. So let's look at NSS temp. What exactly is NSS temp? So if you see, it basically looks like some sort of data, but now when you look at it, do you see the starting values? AA, EA, AAD ///, which means this is indeed .NET serialized data. So let's go ahead and see what we can do. So I take this information, I go to my browser, I go to visoserial.net and I try to generate a payload. So I use the gadget called as type confused delegate, which is a part of the .NET serialization payload sets, and I use the particular formatter called as BinaryFormatter, which we believe is the default formatter used most of the times in the .NET framework, and I create the payload that I want to get executed. So I say PowerShell.exe, invoke web request, I call my IP address, and I use this particular env username, right? So env username is nothing but within a PowerShell trying to access the particular environment variable called as username. So I click on generate, it creates this particular payload. I copy this payload and I first start a listener to understand whether my attack succeeds or not, right? So I start a simple Python server running on port number 8888 because that's exactly the payload for what I generated. I put my payload here and I send it. And I wait for the execution. Now, if you see, it's successfully executed and it told me the username of the web server on which I was able to perform the .NET serialization attack. It is a Win2K12 server. That's the name of the particular server that is running. And this is how you exploit .NET serialization vulnerabilities. Now, obviously, during the class, we go ahead and try to understand in detail what are the different things that you need to follow. But to add something to it, this is how you go ahead and take a reverse shell. So I've edited the IP address to my IP and the port number, and this particular script that you see is a small PowerShell script that allows us to take a remote code execution and take a shell on the attacker's machine. So let's go ahead, create the payload for this. So I generated the payload. I'll copy this data and I'll resend it in my repeater value. So I'll first start the listener. So I said nc-nlvp on the port, and now I will send the payload. So let's remove the old one, put the new one, and hit send. Awesome. So if you see, we've got a shell, and this is exactly how you exploit .NET serialization vulnerabilities, right? So you can run all the commands that you want, and from here onwards, you can elevate your privileges or pivot within the network and present your test case to the company that you're pen testing for. Another interesting attack, SQL injection. Now, we all have seen SQL injection in our day-to-day lives, and that's one of the most common vulnerabilities that if you find leads to a very critical rating for an organization or a very critical finding even for your bug bounty operations. Now, how or what exactly is SQL injection via crypto? So let's go ahead and have a look at it. Now, most of the times, if you see in an application, third-party interaction requires you to transfer sensitive data, sensitive information like payment or financial data like your credit card details or your wallet details, etc. And when third parties are involved, you always have to ensure that the data is encrypted to provide protection to your client data. Now, if at all the encryption mechanism that is being used is exposed accidentally, maybe the key is leaked, or you're using some functionality within the application that uses the same encryption key, but it is not well protected, then the attacker can leverage and make a lot of damage using crypto-based attacks. So to give you an example, just to understand a normal transaction flow between a third party, and e-commerce application. What exactly happens? Step one, a user initiates a payment process, right? The user enters the CVV number, the credit card number, CVV number, phone number, address, etc. Hits submit. This information is sent to the actual e-commerce backend, where it uses a particular key that has been agreed upon by the e-commerce application and the payment gateway, and the credit card data has been encrypted and sent back to the user, and the user is redirected to the payment gateway. Now, since the key is only available between the two of them, there's no way an attacker will be able to intercept this particular data. But what if this same key has been used in the application somewhere that is exposed, and it leaves some information, or it leaks some information? That's exactly what we're going to see. But before that, I'll give you a little bit of more understanding on blind injections, right? So blind injections are basically scenarios where you do not get a response in return. You have to force a response from the server side. Now, usually when we talk about blind injections are cases where we send in a payload, but we do not get any response in return. So how do we identify blind injections? We have to use something called as out-of-band techniques. You have to force a request from the server to send a request either as an external service itself, or maybe over DNS channels, FTP channels, or HTTP channels to let you know whether the particular service is vulnerable or not. Now, different SQL platforms have various inbuilt functions which can be used to exactly identify and exploit these types of blind SQL injection scenarios. To give you an example, master.sys.xpdir3 in MS SQL is used for multiple purposes such as listing files, but you can actually leverage this particular stored procedure to make an out-of-band call request for you and tell you whether an application is vulnerable to SQL injection or not. So let's go ahead and just see a demo of how we identify endpoints and we do exploitation of SQL injection via encrypted payload sets. Okay, so I'm going to play this video. Let's go ahead and have a look at it. So this is a top-up application and it allows you to purchase top-ups. So I'll go ahead, select one random top-up. I'll click on order and I'll probably try to apply the voucher, right? So when you're testing for vouchers, you basically see how the voucher functionality behaves. So I give a simple test and we hit submit. Now, when I turn on the intercept and I check how the request responds, it's sending code as test. There is a protection, a signature value which leads like this, which protects that particular parameter from being brute forced, right? If the user wants to brute force that particular code parameter, they will have to find out how the signature is generated and then be able to pen test that particular code parameter. So the developer might have thought that, okay, since I've put this value in place, it will be difficult to pen test that code value. But let's look ahead of that. Let's see what happens next. We receive a response that has the value code is equals to something encrypted, or it's basically a base64 encoded value, because in the end it looks like double equal to. So let's verify our doubts. We paste it, decode, but it's an encrypted value, so it's a no-go. So I know one thing, that I was able to put a clear text voucher test123 and it responded me with an encrypted base64 value, which means it is encrypting it in the backend. Now, how can we leverage this? So let's go ahead and just complete a payment. So I fill in some data. So this is our payment gateway, which we have deployed in our network. And obviously it is a fake payment gateway. So obviously wrong credit card details will work. So we hit on pay and we let the payment go ahead and complete. So if you see, the payment is completed and here is the amount and the data. Now, if you go on the email which you have registered to do this particular transaction, or the email that is registered on this application to use it, will receive two emails, the order confirmation and payment received. So let's go ahead and check both of them. So amount received, and let's check the invoice. Order confirmation, it says click here to view your invoice. Now, this is the additional endpoint that most of the scanners will never figure out. because it requires a manual intervention from the user. And these are the endpoints that often go untested if not properly looked at. So let's see what the attacker does. The attacker clicks on view now, right? So let's turn on the intercept. And there's this request that is going, right? It contains transaction ID and it is encrypted. So I'll take a copy of it. I'll send it to repeater. Let's see what are the other requests. So response, another request on API order. And again, transaction ID, that is an encrypted value. So I'll send this to repeater as well. And we let everything go forward and there's no other information. So now I have these two encrypted places. I need to create payloads for it. Now I know that the voucher payload that was there, when I entered clear text information, it gave me encrypted values. So why don't I create my SQL payloads from this voucher functionality? So I use the wait for delay to go ahead and make the database go to sleep for some seconds. That's an MS SQL, so we'll use the wait for delay. Obviously, it will say that the voucher is invalid because it's not a valid voucher, but the response will give me some encrypted data, right? So the request is wait for delay, and the response is this particular code. So I'll copy this code and I will put it in the two requests that I have captured to understand whether it is vulnerable to SQLi of crypto. So let's paste it here. The first request, paste, send. Nothing. It did not go to sleep for 5 seconds. So maybe this is not vulnerable. Let's try the second one. So I paste my payload and I send. Well, what do we have here? It's in a waiting state. And it responds exactly after 5 seconds, which means my payload worked. So if you look at it, while pen testing and keeping an open eye, we found out that some functionality in the application is revealing some info that is nothing. It's just taking clear text information and giving encrypted information in return. And another endpoint that is often never found by automated scanners because it requires a manual intervention had a particular parameter that accepted encrypted values. And that particular parameter was vulnerable to SQL injection. And it says for itself that there's no way automated scanners can find it, but an open eye or knowing that these kind of techniques exist would enable you to do these kinds of attacks, right? So I hope you all guys like that. And which brings us to the last topic for our today's webinar, that is cloud attacks on SSRF exploitation. Now, the key premise of cloud computing. Now, if you see, there's a lot of buzz around cloud because most of the organizations would want their systems or would want their information to be on the cloud. They want their services to be provided on the cloud. Why? Well, it has a shared pool of configurable system resources. It is decentralized. It can provide you rapid provisioning. You can scale your systems as and when you please. Easy remote access. There's very less minimum management required. And there's obviously no hardware cost. And it is flexible and scalable. So it shows that there's a lot of advantage for organizations to use cloud computing. But we are security testers. Our job is to understand how safe is it, right? So let's go and try to understand. If a lot of organizations are moving, why do we need to address the concern of cloud security? Now, one thing from the security perspective that we all need to understand is cloud services is nothing but shared infra model, which means it's basically a shared hosting and the data of the instances or the servers are all protected by the virtualization mechanism. There are multitude of offerings, which means different offerings have different threat models. Misconfigurations can increase the threat, and an attack or a successful attack in the cloud environment can not only lead to loss of data and productivity, but it can also lead to a huge monetary loss by means of unauthorized softwares or servers running under the account. To give you an example, CodeSpaces had to basically shut their shop because of AWS credential theft. CodeSpaces was a very big organization and it had a lot of big clients, but because of their AWS credentials that were stolen or leaked accidentally, the attackers managed to delete everything that belonged to them. The production servers, the backup servers, the client data, the company data, everything gone. And because this is a shared hosting model, if it is once deleted, it cannot be recovered, which means the organization has no way to come back or restore the damages done, and the companies had to shut shop. And that is why it holds a big danger for people who are not aware of cloud security and deploy their systems on the cloud. Now, this is an aggregated responsibility matrix that we have created. So you have on-premises infrastructure as a service represented as IaaS, platform as a service PaaS, function as a service FAAS, and software as a service as SaaS. So the more you go to the right, the less the responsibilities the users has to take on his hands, and the more responsibility the providers take on their plate, right? So we'll be looking at one of the test cases, and we'll see what that happens. Now, what exactly do attackers focus on cloud environments? The attackers focus on something called as metadata APIs. Metadata APIs are nothing but information about the systems, or information or the health about the systems. So the API URL is 169.254.169.254. They are all available on all the famous platforms: AWS, Google, Azure, etc. Now, what can you do with the metadata APIs? Now, to address how can metadata APIs be accessed by the attackers, let's have a look at it. So SSRF vulnerabilities are basically vulnerabilities that can be leveraged to fetch metadata API. SSRF is nothing but forcing a server to make a request on behalf of you. And metadata APIs can only be accessed if the request is made by that particular server, which means if a server is vulnerable to SSRF and there are no protections to access the metadata API, then the attacker can steal everything that is available in the metadata API list, which means if there is something sensitive, if there are keys, they can be stolen. So Google platform had query v1 beta 1 as their metadata API, which had no protection against SSRF. However, the new v1 protocol that is being used has an SSRF protection with an additional header called as metadata flavor, whereas Azure also has metadata true. But AWS is still finding a workaround because they do not have an SSRF protection. And if there is no protection available, there can be a lot of damage. So this is the case study which we are going to show you. This is one of the real world examples that has happened, where an organization has simply gone ahead, created a web application, and the application was vulnerable to SSRF. They had a CI/CD pipeline, and the amount of damage that could be done just because of this SSRF vulnerability was catastrophic, right? So this is the last exercise of the day. We'll go ahead and have a look at it. So I'm going to go ahead and play the video. So this is one of the applications, cloud.webhacklab.com, hosted on the cloud environment, and it has a parameter vulnerable to SSRF. Now, the first thing that we do is, when we know it is a PHP application, we try to access something called a server status page, because most of the time server status page is not visible to the external users. It is only accessible to the internal IP. So if I access the server status page, it says forbidden. You're not allowed to access because I'm from the outside. So I'll just capture this request, and I will use that doc parameter to see whether it is vulnerable to SSRF or not. So I send this to repeater, and I replace the doc parameter with localhost server status page. Bear with me, this will just take 2 minutes and you'd love it. So this particular page is accessible, which means that the doc parameter is vulnerable to SSRF. Now, since this is hosted in the cloud environment, let's go ahead and see if we can access the metadata API. So I'll say 169.254.169.254 and forward the request. So we have the response. So I access the latest API, metadata API, and I go into something called as IAM. Now, why do I go into IAM? IAM is identity and access management for this particular box, which means if there are keys in this, this is the identity that is used to access this particular box. So I'll access security credentials, AWS Elastic Beanstalk EC2 role, and I have data. I have access key ID, secret access key, and token. Now there's one more thing that I need to know is the region where it is hosted. So let's just paste the data and let's collect all the information before we begin the attack. So I'll go ahead and also try to locate where is this particular instance located. So I'll go to dynamic instance identity. Yeah, just a change here. And document. And within this, it will tell me the region where it is hosted, that is US-East-1. All right, so now let's go ahead and attack it. So I'll configure my AWS CLI. I'll create these variables. I'll fill in the access key ID. Now I'll go ahead and fill up the secret access key. And I'll paste it. And I'll put the token. And after the token, I will go ahead and put the region. So I'll copy the token, copy it, paste it, and I'll set the region as US East 1. Okay. Now I'll first verify whether I have the proper credentials. So I'll say AWS secret token service, get the caller's identity, and hit enter. If it is valid, it will give me a response with the user and its ID. So let's have a look. It says, yes, it is a valid user and this is the role associated with it. So I'll try to list the buckets. So I'll say S3 AWS S3 LS to list, but it says access denied. Now, someone who is new to the cloud environment would give up at this point saying that, okay, I'm not able to access the S3 buckets using this particular key. But one needs to understand when someone has created a default container or a default Elastic Beanstalk instance in AWS, there is a different way to query the S3 buckets. And what is that? This is how we do it. We say AWS S3LS, the ARN, that is S3 / Elastic Beanstalk, the region followed by the ID. Right? And once you give that, you hit enter. So you'll get the data. And now you see there is a zip file that is available in this particular S3 bucket. So I'll simply try to download this. So I'll create a folder. Let's go ahead and create a folder and let's cd into it and download this particular zip file to understand what exactly is happening. All right, so I'll say AWS S3 copy, that is CP, followed by the particular URN and then a dot to download it in the particular folder in a recursive format, which will basically download everything that is there. And let's just wait for it. Yeah. So if you see, it's downloading everything that's available on this particular bucket. Let's have a look at it. What's available? So there is the zip file, which contains view_post document.php. And if you see, we are accessing that particular document itself, which means that this might be the particular web server that is used to push the data on the production server. So as I said, it's under a CI/CD pipeline. And when we sit during the training and we do an analysis of the entire zip file that we downloaded, we find out how the CI/CD pipeline has been configured and how can we leverage it to upload our own shell. So now what I'll do is I'll simply copy a web shell. I'll take a web shell in this particular directory, right? So let's copy a web shell. And now what I'll do is I'll push this web shell into the zip file. So I'll say zip attach to this particular zip file, this web shell, and verify whether the web shell has been put in, and push this particular new zip file in this S3 document, in this S3 bucket. Right? And now I'll try to access. So if you see it's saying not found, but once the CI/CD pipeline executes, if you see it has uploaded it successfully, we'll wait for some time. We'll try to refresh again. It says not found. Maybe the CI/CD pipeline has not completed itself. Refresh again. No luck. Give it another try. There you go. The CI/CD pipeline executed after X number of seconds, and your web shell has been pushed to the production environment, and you are able to execute code. Isn't this crazy? So imagine if a user or an organization who does not have enough knowledge of having a cloud infrastructure and they use this, just one small vulnerability like SSRF can result into remote code execution, right? So these are the different types of attacks that we teach in our class, that is the advanced web hacking class. And there are a lot of labs. There are a lot of labs around different attack vectors and different test cases and different scenarios which require out of the box thinking. And there is no reliance, or we don't depend on automated scanners to teach you anything that is there in this course. Everything that is done is all a part of manual reconnaissance and manual attack methods. So with this, I would like to thank you all. I will hand it over to Alan, who will explain to you about the upcoming courses and the upcoming trainings that we have. Alan, over to you.
Thank you very much for that. As you probably gathered, there's quite a lot of information on that one, and I hope you found it really interesting. The slides, and I believe there's also a recording that could be made available. So there's quite, like I said, there's quite a lot to cover. So if you wasn't able to scribble stuff down, feel free to contact us. Our website is available to give details of a lot of public courses we have available, but we can also run dedicated courses for organisations. So let's just say you've got 5 or more people, we can probably run a course in your time zone for your company at some very preferable rates. So please let us know about that. Like I mentioned at the beginning, just for attending this, we can offer you a discount code of 20% on any training courses you do. And if you also want to chat to us about any of our training courses or even pen testing, just by chatting to us, again, we will enter you into free prize draw. So yeah, it's a bit of a win-win really. So please contact us as soon as you can. So yeah, that's probably a bit about it from us. You can see the links here, but we can copy you, and you can also get these details from our website. So please do that. But for now, just to finish off for the day, what we're going to do is hand you back to Lizzie for any questions that have been raised during the talks, and that way we can get those answered for you. Lizzie.
Hi, thank you, Alan. Thank you, Dhruv, and yourself for this really detailed and interesting webinar there. So I know we've run over a little bit, so thank you all for staying. We do have a couple of questions that have come in, so if I could pass them over to Dhruv so he can answer them, and then yeah, so that's great. So Dhruv, one of the questions that we've got is, what is the lab access that is available with the trainings?
So once people register to the lab, it's accessible for another 30 days as a complimentary extension where they can actually pen test all the vulnerabilities. And the interesting thing is that the course is an ever expanding course. So every time there's a new technology that is in place or a new attack that is in place, we incorporate that in the lab, and something that is old gets discarded. But when it gets discarded, we do not remove it. We keep it within the lab for people to play. So if you register over a period of time, there's always new content that is available, and the old content is still there, which allows them to explore things that were not taught in the class but still available in that particular network.
Great, thank you for that. Thanks for answering that question. Another question that we've got in is the training team available post-training for doubts regarding any of the topics that are covered in the course?
Right, correct. So as long as you have access to that particular training lab, like once you complete the training and you have the 30-day lab time period, if you have any doubts about any topic, that concerns the content that has been taught, the content that has been not taught, or any doubts you have about whatever has been explained will all be taken care of during the 30-day period that is there.
Great, thank you for that, Dhruv. And then the last question that we've had in now is there any dependency on language to attend the trainings at all?
There's no major dependency on the language because the whole idea of this training is focused on identifying and manually exploiting the issues with the help of available open source scripts and tools that are there. But eventually, at one point of time, when you try to automate stuff, once you're done with this class, you might want to take up a little bit of programming to automate certain set of steps.
Fabulous, thank you so much. So that is all the questions that we have today for this webinar. I want to thank everybody for coming along to it. We do, after this webinar ends, have a few survey questions. If you would be available to fill them out for us, we'd be really grateful. We want to try and improve on these webinars with things that you want to see and want to hear about too. And also, I will be sending out an email tomorrow with a recording and a handout of the slides too, so you won't miss anything there. So yeah, thank you again to Dhruv and Alan for that amazing presentation there, really interesting. And yeah, I hope you all have a good day, evening, wherever you are in the world. So thank you again for attending the webinar. Goodbye, everyone.
Thanks, everybody.
Thanks, bye.
Thank you.